Okay, so checkpoint 1, we want the first 6 terms of the arithmetic sequence in which a of 1 is 100, and I get my next term by just subtracting 30 from my previous term. So a of 1 is 100. A of 2 will be a of 1 minus 30. So 100 minus 30, I get 70. A of 3 is a of 2 minus 30. So 70 minus 30, I get 40. A of 4 will be the third term minus 30. So 40 minus 30, I get 10. A of 5, 10 minus 30, so I get negative 20. And a of 6 is negative 20 minus 30, so I get negative 50. So pretty straightforward. It's a lot of what we did in the first lesson, but now it's a special type of pattern. It's just adding or just subtracting. It's not like we're mixing multiplying and subtracting or division and addition, stuff like that. Now the general term of an arithmetic sequence, I would highlight this. Okay, this is going to be very useful with the rest of this lesson when it comes to basically instead of constantly finding the first, then the second, then the third, then the fourth in order to be able to find, let's say, the 10th. Instead of going through all that work, this is a nice way of basically figuring out how can I jump ahead and save myself time. All right, so basically what it's going to be is any term you want, you're always going to take the first term and you're going to add your common difference n minus 1 times. Now, why n minus 1 times? All right, so let's think. Let's look up at checkpoint 1. To get from my first term 100 down to my fourth term of 10, I had to subtract 30 1, 2, 3 times. So I had to minus 30 3 times, which 3 is 1 less than 4. If I wanted to go from my second to my sixth, okay, I had to go 1, 2, 3, 4 spaces, so I'm going to subtract 30 4 times from 70, and I'll get to it. So it's a nice way of kind of being able to jump without having to find all of your terms completely. Okay, so if I want to use the general term to find the 8th term of an arithmetic sequence whose first term is 4 and whose common difference is negative 7. So I want my n to be 8, my first term is 4, and my common difference is negative 7. So a of 8 equals my first term plus, if you want to write it like where the common difference n minus 1 times, you could write it that way because of the like it doesn't matter. All right, the d can come before the parenthesis or after. At the end of the day, you're still going to multiply. So my a of 8, well, the n is 8, right? My common difference is negative 7, so plus negative is minus, and my a of 1 is 4. So I now got to follow PEMDAS. So 8 minus 1 is 7. Negative 7 times 7 is negative 49. And 4 minus 49 is negative 45. So that's a of 8. Now, something that I may ask you within the formula, within your homework, okay? If I ask you to just give me the nth term, okay? Find a of n, all right? You're just going to write it as a of n equals your a of 1, which in this case is 4. And then you can write plus n minus 1 times negative 7, or you can write it as minus 7 times n minus 1. Either one is fine. Just if I ask you to simplify your answer, now only if it has to simplify your answer, I want you to actually simplify this a little bit to get rid of your parentheses, kind of just make it one solid term. So if I do that, right, I'm going to distribute my negative 7 So I get 4 minus 7n plus 7. And I'm going to combine my like terms. 4 plus 7 is 11. So really, a of n is going to be the same thing as negative 7n plus 11. This is the simplified nth term. Okay? This is not simplified. Sometimes my math lab will ask you to simplify. Sometimes it won't. Okay? So just kind of notice if where they want you to write a of n equals, and you see the little box, if next to it says simplify your answer, then I want you to simplify. If it doesn't, you don't have to. You can leave it in the original general term form. So I would like you to pause the video and try checkpoint 2. Okay, I want you to find the nth term and also find a of n. And I want you to give me the simplified answer. Okay? All right. So the ninth term, so n equals 9, of the arithmetic sequence, whose first term is 6, and whose common difference is negative 5. So a of n equals 6 plus 9 minus 1. Oh, let me put the n as 9 plus 9 minus 1 times negative 5. That is my general formula, right? So I'm just going to do my PEMDAS. So it's 8 times negative 5, which is negative 40. So my ninth term would be negative 34. Now, if I wanted you to find the general term, give me that general formula for finding any term. It would be a of n equals my first term 6 plus n minus 1 times negative 5. So what I'm going to do is I'm going to distribute the n to the negative 5 and the negative 1 to the negative 5. And I'll get 6 minus 5n plus 5. 6 plus 5 is 11, so this is going to be a of n equals negative 5n plus 11. Okay? Remember this term here, that 11, it's just because your first term is 6, and if the pattern is to minus 5, what would have came before 6? It would have been 11. So it's like that a of 0, your y-intercept. Okay, so word problems. So we could apply some of this to word problems. Okay, it all depends on if I say how the trends are projecting it to happen. Is it going every specific amount where I'm minusing or adding, or am I going to be multiplying? Okay, but with the multiplying, we'll get into that with 10.3. So let's read this problem. So the graph in figure 10.4 shows the percentage of the U.S. population by race ethnicity for 2010, with projections by the U.S. Census Bureau for 2050. So basically they're showing as it progresses from 2010 to what they project it's going to be by 2050. Now the data shows that in 2010, 64% of the U.S. population was white. On average, this projection is to decrease by approximately 0.45% a year. So it's going to decrease by 0.45%. Okay? Now, if we use all percents, then I really don't have to worry about changing the percents to decimals. I could just leave everything as percents. So the first thing, write the formula for the nth term, so they want a of n, for the arithmetic sequence, so we know it is arithmetic. Come on, pen. That describes the percentage of the U.S. population that will be white n years after 2009. So if we're talking about n is how many years after 2009, then 2010 would be your a of 1. All right, the year 2010. It's 1 year after 2009. That's why they wrote it that way. So it was 64% in 2010, so that's going to be our first term. So our common difference we found to be to minus 0.45% a year. So now to find my nth term, a of n equals my first term, 64, plus n minus 1 times my common difference, negative 0.45. Now let's try and simplify this a little bit, just so it looks a little cleaner. So the negative 0.45 will multiply into the n and the minus 1. So I get a of n equals 64 minus 0.45 n plus 0.45. So a of n is negative 0.45 n. Now I'm going to add my common terms, and I get plus 64.45. So this is my general term. And now that I have a general term, I can use this to kind of find any projection for any year. Now, B says what percentage of the U.S. population is projected to be white in 2030? Now remember, this is only for white. It would be different for everything else because the percentage increase or decrease would be different. So 2030, basically we could use this formula. All right, the a of n equals negative 0.45 n plus 64.45. But now what we're going to have to do is figure out, so for the year 2030, my n, how many years have passed from 2009 to 2030? So basically, if I do the subtraction, I'm going to have 21 years. All right, so my n is going to be 21 that I'm going to plug in to figure out this projection. So I'm going to find a of 21 to figure out that projection for the year 2030. And I'm going to do negative 0.45 times 21 plus 64.45. When I do that, let me look at my notes. I am going to get, when I multiply the 21 to that, I'm going to get negative 9.45 plus 64.45. And I will get for a of 21, 55%. So the percentage of the U.S. population that will be white by the year 2030 is projected to be 55%. All right. I would like you to pause the video and try out checkpoint 3 and see how you do. All right, so 16% of the U.S. population was Latino. On average, is expected to increase by approximately 0.35% a year. So my formula for the nth term, again, since 2009, so my nth term will be, I'm going to start at 16%, and I'm going to add 0.35 and minus 1 times. Okay, remember the 0.35 can go in front or behind. So when I simplify this, 16 plus 0.35 n minus 0.35, I'm going to get 0.35 n plus 15.65. That'll be my nth term. Now for B, for 2030, I'm going to use this formula again. Remember, 2030 is going to be 21 years. So I'm finding a of 21. So I'm going to do 0.35 times 21 plus 15.65. 0.35 times 21 is 7.35 plus 15.65. I'm going to get 24%. So it's projected to go up to 24% by the year 2030. Now, an arithmetic series, once you see the word series, this is going to be your key identifier to add the terms, okay? When it's talking about series, I want to figure out the sum of all the terms that they are talking about. They'll say the first 20 terms or the first 50 terms, something like that. Now, the formula for the arithmetic series, all right? So we can only use this if it has the arithmetic pattern of constantly adding or subtracting. Then we can find the sum of them instead of just like figuring out all the terms and adding them up. What we could do is we can just use this formula. So n divided by 2 times the first term plus the last term. Okay? Now, let's see how this works. Now, why does this work? Okay, let's say I have, let's say the pattern is 2, 5, 8, 11, 14, and then 17 and 20. Okay? I'll go up to 17. So, why does this work out? So I know these sum up to be, let me do the math real quick. 2 plus 5 plus 8 plus 11 plus 14 plus 17. It adds up to 57. Now, the reason why the pattern will work, okay, I want you to kind of look at the first and the last term real quick. 2 and 17. What is 2 plus 17? It's 19. Now, look at the next outside terms, 5 and 14. What do 5 and 14 add up to? 19 as well. And then 8 and 11 also add up to 19. When you work from the outside and pair them up and work your way in, they'll always add up to the same thing. So instead of just adding all of them up, you can take that 19 and add it 3 times. Now, why 3 times? There are 1, 2, 3, 4, 5, 6. So 6 terms. Cut that in half because you're pairing them, it's 3. That's where that n divided by 2 part comes from. So we add the first and the last term half the number of times together. Now, if you had an odd number, okay, let's say that 20 is now there. Okay, we now have 7 terms, right? So that's like 3.5 groupings. So, well, if I added this, I'm going to get 77, right? Same thing, 57, just add that extra 20. Now, if I look, 20 plus 2 is 22. 5 plus 17 is 22. 8 plus 14 is 22. And then if you have that only number left, it's always going to be half of whatever the 2 added up together as. That's why that 3.5, so 3 22s added together, 66, plus half of 22, which is 11, you're going to get that 77. So I always like showing how this pattern kind of works and why this formula does work out the way it does. I just find it interesting. So because of that kind of common occurrence, this is why we can make this formula. This is why it works. Okay, now, big thing to keep in mind. If you are ever missing the following things that you need from this. So what you need in order to do this is you need your n, your a of 1, and your a of n. So the number of terms you need, your first term and your last term. You need those 3. If you are ever missing any of those things, you are going to go back to the arithmetic sequence formula to find that missing piece. Okay? You will always have enough information to be able to find your missing pieces. So if you don't have everything to do a series, you go back to the sequence formula to find those missing pieces. So find the sum of the first 100 terms of an arithmetic sequence that's 1, 3, 5, 7, and so on. So I know it's an arithmetic sequence, okay, because I see the pattern. The pattern is to add 2, so that's my common difference. My first term is 1, and then it wants the first 100 terms, so my n is 100, right? Now, I don't know what my a of n is, right? But I have enough information to be able to figure that out using the sequence formula, okay? So to figure out what a of 100 is, I need to take my first term and add it to my common difference, 100 minus 1 times. So a of 100 equals 1 plus 2 times 99. Okay, 2 times 99 is 198 plus 1. I get a 100th term of 199. Okay, you have to use the sequence formula in order to figure this out. Now that I have all my pieces, I now can go on to the series part of it. Okay, so when you see capital S, that means series for sum, right? Sum of the first 100 terms is going to be 100 cut in half times the first term plus the last term. So it's going to be 100 cut in half is 50 times my first term is 1 plus my last term is 199. 1 plus 199 is 200 times 50. I'm going to get 1,000. So basically, if you want to know what all of this adds up to, your first 100 terms, you got it. It's 1,000. Now I want you to try checkpoint 4 on your own. Good luck. All right, now to find the sum of the first 15 terms of an arithmetic sequence. So we know we're going to use for sum S of n equals n divided by 2 plus a of 1 times a of 1 plus a of n. So I have my n, my first 15 terms. My first term is 3. My 15th term, I don't know. They just gave me the first 4, right? But I can find that by using my sequence formula. Remember, whenever you're missing something, you just use the sequence formula. Now, my common difference, if I look, the pattern is to just add 3, add 3, add 3. So that is my common difference. So a of 15 equals my first term, which was 3, plus common difference was 3 times 14. 3 times 14 is 42, plus 3, we're going to get 45. So now I have my 15th term. So now I can figure out the sum of the first 15 terms by doing 15 cut in half times the first term plus the last term. So 15 cut in half is 7.5. 3 plus 45 is 48. And then when I actually multiply these two together, I will get 360. Okay, so remember, we're talking about sequences is finding a certain term. Okay, so sequence, just something to keep in mind, is used to find a specific term. A series is to find the sum of the first n terms. Okay, series is with sum, sequence is to find a specific term. Now, if I give you one of these sigma summations, right, you can kind of use the series option if you notice that the pattern is arithmetic. So remember, arithmetic sequences are linear, right? So if you see your pattern is a linear function, you can kind of go back to the idea of the arithmetic series in order to find the answer. Because who wants to sit there and plug in 1, 2, 3, 4, 5, all the way up to 25 and then add all of those up together? It's going to take too long. So if you notice, since it's linear, you can use your arithmetic series formula. So S of n equals n cut in half times a of 1 plus a of n. Now, your lower limit, okay, 1, that's going to be what you plug in to find your first term. So my first term is going to be 5 times 1 minus 9. 5 times 1 is 5, minus 9 is negative 4. Now, luckily, since it starts at 1, all right, I'm going up. I know my first term. My top term, my last term is going to be the 25th. So 5 times 25 minus 9 equals 5 times 25 is 125. Minus 9 is 116. Now you got to think, how many terms were there all together? There was 1 all the way up to 25, so there were 25 terms. Okay? If I didn't start at 1, let's say I started at 3 and I went 3 to 25. Okay? Technically I was using 23 numbers, so I have to keep that in mind when it comes time for the n over 2. All right? But luckily I don't have to worry about that. So I'm going to find the sum of those 25 terms. I'm going to do 25 cut in half plus times negative 4 plus 116. So 25 cut in half is 12.5 times 112, and what I will get is a sum of 1,400. So instead of sitting there finding all 25 terms and then adding them all up, you notice it's linear, so use the shortcut of the arithmetic series. Now, let's see if you truly get this. I want you to try check 0.5 on your own. Good luck. All right, so hopefully you paused the video and tried it on your own. And if you did, you should have gotten an answer of 2,460. Okay, and this is why. You see your pattern. It is a linear function. So since it's linear, you can use the arithmetic series formula. Now, what you're going to need to do, your lower limit is 1, your upper limit's 30. So in total, from 1 to 30, you are using 30 terms. Your first term is going to be 6 times your lower limit 1 minus 11. 6 times 1 is 6, minus 11 is negative 5. And then to find your 30th, 6 times 30 is 180, minus 11, we get 169. So I plug this into my arithmetic series formula. S of 30 equals 30 cut in half times negative 5 plus 169, which 30 cut in half is 15. Negative 5 plus 169 is 164. And 15 times 164 is going to give you 2,460. All right, so that is everything for 10.2. If you have any questions, please do not hesitate to reach out to me. Be careful with the wording and the directions that they want for the homework on my math lab. The last problem is a word problem about kind of figuring out who's going to make more money over time with their raises and everything. So it's kind of using within a word problem, applying this arithmetic series and sequence information. Okay, good luck. Any questions, reach out to me. Okay, have a good one. Bye.